Okay, so we are going to learn about electron configuration, but before we do that, we actually have to understand how the atom is structured, starting from the nucleus and then going outward. Okay, so we compare our atom to an apartment building because I found that that's a useful analogy. So I'm going to say here on this right of the screen you can see the drawing. I'm going to say the nucleus is basically the basement, and starting from the nucleus going up, you have these floors or energy levels that go outward from the atom. Now remember that this is a spherical structure, so we're kind of looking at like an upside down apartment building where the bottom floors are smaller than the top floors. Okay, so we label these floors or energy levels with the n numbers, which you should have in your notes, okay? And we call the n levels principal quantum numbers. Principal quantum numbers are basically the main energy levels for electrons inside the atom. So these are main energy levels. All right, I'll be with you in a second. Then you have energy level 1 or n equals 1, which is the closest to the nucleus and it's the smallest. Then you have energy level 2, n equals 2. Then you have energy level 3, n equals 3. And you have energy level 4, n equals 4. Okay? Now, the way that these energy levels differ from each other is by the type of apartment or the type of sublevel they have inside them. Okay? So, remember, this is our atomic apartment building. Each floor is an energy level. And as you go away from the nucleus, the distance to the nucleus increases. And the higher up you are, the more energy you have. And we don't draw levels 5 through 7 because they basically look like n equals 4. Okay? So you can see the red arrow on the left. Energy is increasing as you go up. Okay? Now, the first floor is like a studio apartment. It only has a studio apartment, which means it has a one bedroom apartment, and that one bedroom apartment is where you would put electrons. Now, that space to put electrons is called an orbital. See right here, I have the definition of an orbital. One box is one orbital, and each orbital or each room can hold two electrons. Okay, so the first energy level only has the S type apartment or the S type sublevel. There are four different types of sublevels. It's S, P, D, F. So the next energy level actually has a S type apartment and a P type apartment. And the way they are different is the number of rooms they have. S always has one, P is a three-roomed apartment, okay, which means you can put two electrons in each room for a total of six electrons, okay? Then you have the third energy level, which has a S type apartment, a P type apartment, and a D type apartment. So the third energy level is much bigger and has more room for electrons. S is still one room, P is three rooms, and D is bigger than both of them and has five rooms. Okay? So more electrons. And those electrons will have more energy because the higher you go, the more energy you have. Okay? Now, the fourth level, the fourth energy level, which is very similar to energy levels 5 through 7, have a S type, a P type, a D type, and an F type apartment. Okay? S again is a one bedroom, P is a three bedroom, and then D has five rooms. Those are all to put electrons. And the F type level has seven rooms. One, two, three, four, five, six. There's the seventh room. Seven rooms. So that's how S, P, D, and F differ from each other. Okay? That's why we have letters to describe them. So if I were to put two electrons, I would put the two electrons in the first floor in the first room. Now, there's a rule that says when you're putting electrons in the atom, you have to start from the lowest floor and work your way up. And even within the flows, you have to put the electrons in the lowest energy level first. So that is one of the rules of electron configuration. Now, just to review, an S-type sublevel or S-type apartment is one orbital or one room, and that one room can hold a max of 2 electrons. Okay, a P sublevel, which is a P-type apartment, can have 3 rooms, so can hold 6 electrons. D can hold 10 electrons because it's 5 rooms. 5 times 2 per room gives you 10 electrons. And F is 7 rooms, and 7 times 2 gives you 14 electrons. Okay? Now, we are going to learn how to write electron configurations. I have the rules here, but there are 3 rules you have to follow for electron configuration. That's a T. The first rule is Aufbau's rule. The second rule is called Hund's rule, Aufbau's principle. And the third rule is Pauli exclusion principle. Okay? Now, in the PowerPoint, you have all 3. Oh, by the way, see these different shapes? These shapes are the shapes that we represented as boxes. This is S, remember? 1 box. This is P. Yeah, this is P. P is 3 boxes. This is D. See, 1, 2, 3, 4, 5 boxes. And this is F. 1, 2, 3, 4, 5, 6, 7. Now, these are the locations of electrons around an atom, but because these are incredibly complicated solutions to a very complicated mathematical equation, instead of drawing these incredibly complicated shapes, we represent our orbitals as just boxes, and each box is a solution to one of these things. Okay, so when you put all of these little shapes together, you get your spherical atom, and that is why atoms are spherical. Okay, now electron configuration, which is the point of this video, sounds fancy, but it's really not. Okay, electron configuration is basically the way electrons are arranged around the nucleus for every element. That's it. And here are the 3 rules that I just wrote down: Aufbau, Hund, and Pauli. Here is Aufbau's principle. Aufbau's principle is what I mentioned earlier. When you are putting electrons into the atom, you have to start with the lowest energy first. We call them orbitals, each box, lowest energy orbitals first. So if you were putting tenants into your apartment building, you have to start from the lowest floor. Only when that orbital is full can you move on to the next one. Now, even though we want our lives to be super organized, sometimes real life is a little bit different. So look at the orbitals. You have 1s, that's the first energy level. Then you have 2, second energy level, S-type apartment. Second energy level, P-type apartment. Third energy level, S-type apartment. Third energy level, P-type apartment. However, before you go to the third energy level, D-type apartment, you have to fill the electrons in the fourth energy level, S-type apartment. Why? It's because the 4s energy level is actually slightly lower in energy than 3D. So you have to follow Aufbau's rule. Electrons fill the lowest energy orbitals first. So 4s gets filled before 3D. Now you have to follow this order, and this order is a little bit complicated to remember. So because it's complicated to remember, there's an easy way to write it. So this is the way to write it: Aufbau's order. Okay? You start from 1s and you write all the way down to 7s. 1s, 2s, 3s, 4s, 5s, 6s, 7s. Then, remember, second energy level is when you first encountered a P-type apartment. So you go to 2p, no 1p, 2p, 3p, 4p, 5p, 6p. We're not going to use 7p because we're not going to encounter anything with 7p, but it does exist. So I guess I'll just write it. Now, remember the D-type apartment started in the third energy level? So 3D, 4D, 5D, 6D. There is no 7D, okay? Then the fourth or F-type sublevel started in the fourth floor, so 4F and 5F. There's actually no 6 or 7F, okay? Once you have written this, it looks like a little bit like a triangle. You have to use arrows to cross. 1S, 2S. You just cross what's in that same diagonal line. 2p, 3s, then 3p, 4s, then 3d, 4p, 5s, which is why you have to write it really neatly, okay? Then 4d, 5p, 6s, then 4f, 5d, 6p, 7s, then 5f, 6d, 7p. Now, here's how you read this. You start here, always. This is your beginning point, okay? Then you start here and read from the back of each arrow to the front. That's how you write it, okay?